Hey everyone, this is Eugene, and today we're here with Mike, and we're gonna do another live episode of live contract reviews. And today we're gonna review a contract, which is NFT contract. I believe it's for Galaxy Online, and it is based on the one of our examples that are available. So they just got it and modified it to include the game logic into the NFT. Share my screen. Cool. Okay, shift it a bit. Get my camera set up properly. Last time I recorded through Zoom, it was a bit weird. It had some like black bars. It's probably from the overlays of my windows on top of the C-line screen. Okay, so basically it uses nearest decay 310 without without NFT standards. So in a new version, I believe there's a in nearest decay near contract standards, there's a NFT standard that can be used to remove the boilerplate. So it's all pretty standard. So here's a contract, which is based, I believe, on whatever was called NFT simple originally, then it mutated to like NFT market. So right now it probably lives on a, is it in core contracts? Mike, do you know?
It is in the near SDK RS examples, as well as near.dev examples. We have the NFT example updated.
Cool. So it might be a bit older version, but so what we're gonna focus more today is more on a custom logic and like make sure that it's correct overall. So it uses the storage keys, but it doesn't use the Porsche storage key extension, which is kind of removes the need from using try to vec and unwrap. So that's all fairly standard. Token owner inner, and then stores the NFT metadata that is passed in the owner ID. Computes the storage for the longest account. So this is a custom method, set station level that takes a U8 and a token ID. Token ID is a string that verifies that it's called by the owner. Okay, and then it finds the token by ID, which is we only have one instance of a token, I believe. The rest is just references. And it modifies the token and put it back. So it sets the new level of the token. Set license level, so it has the res, then trade and prod. So it kind of like three optional values. Modifies the token and insert it back. Okay, pretty simple. Set station coordinates, takes two coordinates as a U32. And if it was not set, then it sets it. If it was, well, consider it was 0. It's somewhat strange. I would probably expect if this is like more than 0, then you would set it. So, but that's okay. So it's only like allows to set the coordinates once. And about us, it returns the metadata. So that can be unwrapped, so you don't need to return an option because it's unlikely it's not gonna change. So let's take a look at the token. And what is the custom fields? So token has the name, remoteness, level, race, coordinates, and two other things. That is so JSON token is everything that token has plus the token ID. Yeah, that's kind of unfortunate that it has to, oh, it also has metadata, right? Okay. And it doesn't have a next approval ID. Okay, let's see what metadata is. So metadata is spec name symbol icon. That's a standard, and token metadata has a title, description, unique copies issued. It's also pretty standard. Burns. Owner can burn a locked token for a given user, reducing the enumerable NFT supply for type. Is token locked? Is token locked? Because burn is not linked to the leap, so it's not active. Okay. Enumerable, that's I guess a standard that just enumerates on tokens. Internal is also a standard, so it's pretty much this contract is. I guess not that many changes was made, just mostly to modify the token and like provide it. Is there? Okay, here's a here's internal transfer. An internal transfer actually reconstruct the token from a previous token, which creates a bunch of boilerplate. I think you should be able to do something like this now. So you don't have to like write that boilerplate on Rust. Which essentially what it does, it takes these two fields and then the rest of the fields from the token. Yeah, leap we looked, metadata we looked, mint. Okay, so mint is a payable method with a bunch of default data that you need to pass to the contract, including token metadata and an optional receiver ID. Token ID is generated from token metadata by ID lengths. So this might be problematic if you actually have a burn support, because when you remove it from the map, the unordered map size may decrease. So you may instead want to use the total number of minted tokens instead of the metadata lengths. Because let's say you deleted token number 3 out of 5 tokens, and the next token you mint will again have the same idea as a previously minted token because you just decrease this length by 1. So,
Is there something?
Yeah.
I see that there's like payable on this, and there's a comment recently and an issue about this. I'm wondering if they're asserting one Yocto or what, because I was expecting assert one Yocto near here somewhere.
Let's see. It might be like internal mint or something that like checks the storage from the owner or something like this. ID earn owner ID is predecessor. If the receiver is given, then the owner is the receiver. Token ID next approval is 0. Coordinates by default is 0. Then we insert the token. Then we insert the metadata. So this will fail on the next mint after burn. And it's saying figure out what it does. So what it does is we generate a new set for the hash of the owner. Then we insert the token ID and save the set back. And it doesn't do any storage manipulations here. So this payable is actually not needed unless the owner, well, in this case, there is no check for the contract owner, so anyone can call it as well. Which is a problem. Check who can call this method.
It's possible that people looking through our contracts think that payable means it has to receive a payment, but that isn't the case.
No, but no. No. Okay, NFT core. So that's a pretty standard method, I believe. Probably nothing has been modified here. Yeah. And NFT approve. So it's all pretty standard. NFT revoke all, total supply. Not sure what's just changed. NFT token is returning a token plus a bunch of, again, metadata. So that can be replaced. Token. It's probably not going to work because they're two different types.
And as a little aside, like learning opportunity, like the reason why someone would have a JSON token versus token is probably like the key is the token ID and the value is the token. But then when you're returning it to an end user, you also want the key in there, right? And so that's why they made JSON token to kind of shim that in there.
Metadata.
And metadata.
But then what you may do is just like in JSON token, you have like sub token or something. I don't know. subfield token. It's also possible to flatten it somehow. This Serde allows you to like manipulate this type of stuff.
Yeah, you can say skip serialization.
You
There's
can
other stuff
probably
like that.
do like include token, and then within this token you can do something Serde flat and something. I don't remember the exact mechanics, but what it will do is it will take this out, and then all the fields of token will appear in this object.
Cool. Didn't know that one.
Maybe it's for enum, but Serde is so flexible, so it probably has some kind of option which will increase your contract size by 30 kilobytes, but then give you a nice nice code. Yeah, but the problem is like, if you actually need to return token, which I don't think you need, so maybe you can remove the serialize out of token, and then or actually like somehow manipulate the serialize, so like skip deserialization or add serialization, then you can manipulate this with Borsch as well. Either way, let's look at the, well, actually we looked at everything, including core returns, inner refunds. So that's pretty much it. So overall, yeah, the contract seems like works fine. I'm not sure how extensible is our standards and like whether you can modify that, like, or add these custom fields. Probably not directly. So that's why a lot of this stuff is needed. But potentially we can do some custom field on a token that is a generic that has these properties, which allows you to actually extend the NFT standard in order to include these fields into the token. And all of them can go to like custom metadata, or like custom. And then on the front end, you just need to like get them separately.
Would you mind going to the burn.rs real quick?
Yeah.
It's 2 to the right of the, yeah, there. It's like one small thing I wanted to note. I added a Stack Overflow answer a couple of days ago. So you notice how there's near bind gen and then impl contract. My IDE and maybe your IDE will think that you can just say use create contract, but it won't work. So note here that on line 1, use create asterisk. That's kind of an important thing. I noticed that and wanted to point that out in case you ran into errors.
Yeah, basically it just imports everything from the top level module. And in order for this implementation to exist, you actually have to link it through mod. So because the burn is not here, that implementation is not compiled. That's why like it's okay to use the stuff that doesn't even exist in the contract. So there's no such thing as like his token lock. Okay, I guess we're done with this contract. That was pretty simple and fast. So I guess this episode is gonna be pretty easy. So token count is actually incremented when you mint, but not decremented when you burn. So you can use token count here instead. So long as you don't decrement it. All right. So
And tune in next week for cron.
Yeah, next week we'll do the review on decentralized cron. So Thanks everyone. Bye.